Hello, in this lecture we answer two questions. In the first question, we find out the radius of this circle. And in the second question, we find out the area of this semicircle APQB. So let's start with the first question. In the drawing, we have a circle. This is line 7 CP. This is equals to 12 units in Islam. This is line 7 AP. This is equals to 4 units in Islam. This is line 7 PB. This is equals to 4 units. This is angle CPB. That is equals to 60 degrees inside. Again, our task is to find out the radius of this circle. So first of all, it is given us the question that AB is a straight line. AB is a straight line, so if you focus on the upper side of the straight line AB at point B, here the sum of the areas must be equal to 180 degrees according to rule 3. Rule 3 states that the sum of the areas on one side of a straight line is equal to 180 degrees. So which areas we have at the upper side of the straight line AB at point P? We have this angle that is equal to 60 degrees in size, plus this missing angle. The total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 120 degrees in its size. In the next step, we will join point C and A together by straight line. And we join point C and B together by straight line. When doing those constructions, we can do three triangles. This is triangle CAP, this is triangle CPB, and the big triangle ABC that contains those two smaller triangles. So we'll implement the law of cosines on all the three triangles in the first step. So first of all, we'll implement the law of cosines on this red triangle ACP. So we press query on the law of cosines. According to the law of cosines, this is triangle ABC that could be any triangle. So the law of cosines is true in any triangle. The length of side AB is A units, side AC equals to B units in itself, side BC equals to C units in itself. This is angle BAC that is defined as angle theta. So this side ABC that could be any triangle according to the law of cosines. The following equation is true. C square equals to A square plus B square minus 2 times A times B times cosine theta. Again, C square equals to A square plus B square minus 2 times A times B times cosine theta. So we can actually implement the law of cosines on our red triangle CAP. So according to the law of cosines, in triangle, we'll choose angle theta. This angle is equal to 120 degrees in its size. So in triangle ABC, according to the law of cosines, the following equation is true. CA square equals to AP square plus CP square minus 2 times AP times PC times cosine 120 degrees. And again, in this great triangle APC, according to the law of cosines, the following equation is true. CA squared equals to AP squared plus CP squared plus 2 times AP times PC times cosine 120 degrees. CA squared, CA is the missing side, so leave it as it is, so it is CA squared equals to AP squared. AP is 3, therefore AP squared is 3 squared, that is 9, plus CP squared. CP is 12, therefore CP squared is 12 squared, that is 144, minus 2 times AP is 3, times CP is 12, times cosine 120 degrees. Cosine 120 degrees equals to minus 1R. So we should find out that according to the law of cosines, triangle APC, the following equation is true. CA squared equals to 9 plus 144, that's actually 153. So CA squared equals to 153. Here, minus times minus is plus, so this expression will be a positive expression. We have 2 in the numerator, 2 in the denominator, so 2 will get cancelled. So total this expression equals to 3 plus 2, that is plus 36. So total we found out that CA squared equals to 153 plus 36, that is actually 189. CA squared equals to 189. Here we take root out of this equation, and we get that CA equals to the square root of 189 units. Okay, again, this is side CA, is equals to the square root of 189 units in its length. So let it now. CA equals to the square root of 189 units in its length, and CA squared equals to 189. Likewise, we will implement the law of cosines in this white triangle, triangle CPB. According to the law of cosines in this one triangle CPB, first of all we choose angle theta, is this angle PCCPB that equals to 60 degrees. So according to the law of cosines, this triangle CPB, CB squared equals to CP squared plus PB squared minus 2 times PB times CB times cosine 60 degrees. Okay, again, this in this right triangle CPB, according to the law of cosines, the following equation is true. CB squared equals to CB squared plus PB squared minus 2 times PB times CB times cosine 60 degrees. CB is the missing side, so we leave it as it is, so it is CB squared equals to CP squared. CP is 12, therefore CP squared is 12 squared, is 144, plus PB squared. PB is 4, therefore PB squared is 4 squared, this is 16, minus 2 times PB is 4, times CB, times CB, this is 12. Times cosine 60 degrees. So in total, as we found out that according to the law of cosines, in this right triangle CPB, the following equation is true. CB squared equals to 144 plus 16 minus 2 times 4 times 12 times cosine 60 degrees. So CB squared equals to 144 plus 16 is 160, and we have here minus 2 times 4 times 12 times cosine 60 degrees. Cosine 60 degrees is 1/2. So here we have in total minus 2 times 4 times 12, and cosine 60 degrees is 1/2. So we have 2 in the numerator, 2 in the denominator, so 2 will get cancelled. And we have to only with minus 4 times 12, that is minus 48. So in total, if we found out that CB squared equals to 160 minus 48. 160 minus 48 is 112. So CB squared equals to 112. Here we take out of this equation and find again that the missing side CB is equal to the square root of 112 units in its length. And again, this is the missing side CB is equal to the square root of 112 units in its length. And CB squared equals to 112. In the next step, we define angle PAC, this angle is alpha. And we will implement the law of cosines on the big triangle, triangle ABC. So in this big triangle ABC, we choose angle alpha as theta in the equation of the law of cosines, and get that in triangle ABC, according to the law of cosines, the following equation is true. CB squared equals to CA squared plus AB squared minus 2 times CA times AB times cosine alpha. But again, in this big triangle ABC according to the law of cosines, the following equation is true. CB squared equals to CA squared plus AB squared minus 2 times CA times AB times cosine alpha. We already found out that CB squared equals to 112 and it is equals to CA squared. CA squared equals to 189 plus AB squared. AB in total equals to AP, that is 3, plus PB, that is 4. So in total, AB equals to 3 plus 4, that is 7. AB equals to 7, therefore AB squared is 7 squared, that is 49. Minus 2 times CA is equal to 189 times AB, that is 7. Times cosine alpha. So in total, we found out that according to the law of cosines, in triangle ABC, the following equation is true. 112 equals to 189 plus 49 minus 2 times square root of 189 times 7 times cosine alpha. So 112 equals to 189 plus 49 is 238, and we have here minus 2 times 7 is minus 14, so in total this expression equals to minus 14 times square root of 189 times cosine alpha. So write it down, minus 14 times square root of 189 times cosine alpha. Here we subtract 112 from this equation. So in this side of the equation we left with nothing, that is to say 0. Well, on the other side of the equation we have 238 minus 112 is 126. And here we have minus 14 times square root of 189 times cosine alpha. So remove this expression to the left side. And you get that, or we'll add 14 times square root of 189 times cosine alpha to this equation. You get that in this side of the equation we have 14 times square root of 189 times cosine alpha, and it is equals to 126. So here we will divide this equation by 14, and you get that in this side of the equation we have square root of 189 times cosine alpha equals to 126 over 14 is 9. So total we found out that the square root of 189 times cosine alpha equals to 9. We divide this equation by square root of 189. And we get that cosine alpha equals to 9 over square root of 189. So cosine alpha equals to 9, and we substitute 189 by 9 times 21. So total we found out that cosine alpha equals to 9, and we take 9 out of the root, and the square root of 9 is 3, so inside the root we left only with 21. So in the next step, we divide both the numerator and the denominator of this expression by 3, and we get that cosine alpha equals to 9 over 3 is 3, and 3 over 3 is 1, so in the denominator we left only with square root of 21. So in total, if you found out that cosine alpha equals to 3 over square root of 21. In the next step, we use the following trigonometric identity. Here TA is the abbreviation for trigonometric identity. So the trigonometric identity is as follows: sinus square alpha plus cosine square alpha equals to 1. Here we subtract cosine square alpha from this equation, from this trigonometric identity. And we get that sinus square alpha equals to 1 minus cosine square alpha. Here we take out all of this equation and get that sinus alpha equals to the square root of 1 minus cosine square alpha. And again, on the field, that sinus alpha equals to the square root of 1 minus cosine square alpha. We already found out that cosine alpha equals to 3 over square root of 21. We will square this equation and get that cosine square alpha equals to 3 square is 9 over square root of 21 square is 21. So in total we should know that cosine square alpha equals to 9 over 21. Therefore, we can substitute cosine square alpha in this trigonometric identity by 9 over 21. We do it now, and we get that sinus alpha equals to the square root of 1 minus cosine square alpha. And cosine square alpha is 9 over 21. So in total, if you found out that sinus alpha equals to the square root of 1 minus 9 over 21. So sinus alpha equals to the square root of, we'll multiply 1 by 21 and then we'll divide it by 21 in order to have a common factor with this number. So 1 times 21 is 21 minus 9 over 21. We multiply 1 by 21, then we divide it by 21, so we change nothing because it is allowable to multiply anything by 1. So then if you found out that sinus alpha equals to the square root of 21 minus 9 is 12 over 21. So sinus alpha equals to the square root of, here we divide this number by 3 and then both the denominator of this number by 3, and get that 12 over 3 is 4 and 21 over 3 is 7. So sinus alpha equals to the square root of 7 over 4. Here we take 4 out of the root, the square root of 4 is 2. So inside the root we left only with 7. So it is sinus alpha equals to 2 over square root of 7. And again, in total, if you found out that sinus alpha equals to 2 over square root of 7. And we already found out that CB equals to the square root of 112 units, the square root of 112 units in itself. In the next step, we will implement the law of sines on this big triangle ABC. So repeat quickly on the law of sines. The law of sines is true in any triangle. This is triangle ABC that could be any triangle. The length of side AB is units. Side AC equals to B units in itself. Side BC equals to A units in itself. This is again BAC, that is equals to capital A degrees in its size. This is again ABC, that is equals to capital D degrees in its size. This is angle ACB, that is equals to capital C degrees in its size. And we also have triangle ABC is inscribed by this circle. The radius of this circle is R. So according to the law of sines, the following equation is true. A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. Again, R is the radius of this circle that blocks triangle ABC. So A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. So we can implement the law of sines in our triangle ABC. Well, because here this is triangle ABC is inscribed by this circle. Why? Because of the fact that all the three vertices of triangle ABC lie on the circle itself. A, B, and C lie on the circle itself. Therefore, triangle ABC is inscribed by this circle. So we can implement the law of sines in triangle ABC. According to the law of sines, in this triangle ABC, the following equation is true. CB over sinus alpha equals to 2R. Then CB over sinus alpha equals to 2R. Again, CB over sinus alpha equals to 2R. R is the radius of this circle that blocks triangle ABC. CB is square root of 112. And sinus alpha equals to 2 over square root of 7. So it is equals to 2R. So in total, according to the law of sines, in triangle ABC, the following equation is true. CB over sinus alpha equals to 2R, and CB is square root of 112, and sinus alpha is 2 over square root of 7. Equals to R, to 2R, and R is the radius of this circle, that is the radius that we are looking for in this question. So in total, if you want to know that square root of 112 over 2 over square root of 7 equals to 2R. Here we substitute 112 by 16 times 7. Which is the square root of 16 times 7 over 2 over square root of 7 equals to 2R. We take 16 out of the root. The square root of 16 is 4, so inside the root we left only with 7. And so I found out that 4 times square root of 7 over 2 over square root of 7 equals to 2r. We move square root of 7 to the numerator and 2 to the numerator here. Here we get that 4 times square root of 7 times square root of 7 over 2 equals to 2r. 4 over 2 is 2. So this expression in total equals to 2 times square root of 7 times square root of 7 equals to 2r. Here we divide this equation by 2, and we get that square root of 7 times square root of 7 is 7 equals to r. So we should find out that the radius of this circle, that is the radius that we are looking for this question, is equal to 7 units in its length. So we finish with the first question. In the next step I will present you the second question, and we solve the second question of this lecture. The second question, our task is to find out the area of this semicircle APQB. So, in the drawing we have a semicircle. This is line segment AC, that is equals to 7 units in its length. This is line segment PC, that is equals to 21 units in its length. This is line segment PQ, that is equals to 16 units in its length. This is angle CPQ, that is the right angle. Again, our task is to find out the area of this semicircle. So first of all, we'll define the radius of this semicircle as x. If the radius is x, then the diameter AB is 2x. What is the length of this line segment? Line segment CB. CB equals to AB minus AC. Again, CB equals to AB minus AC. So, as you know, we should find out that the length of the missing line segment CB is equal to AB minus AC. So CB in total equals to AB is 2x, it is the diameter of the semicircle, minus AC. AC equals to 7 units in itself, according to what is given in the question. So in total we should find out that CB equals to 2x minus 7 units in its length. This is, let me say 97 CB, it is equals to 2x minus 7 units in its length. In the next step, we'll complete this semicircle to a circle. So I've completed the semicircle to a circle, and we'll extend line segment PC by a straight line until it touches the circle. We define the touching point of the extended line segment PC with this circle. This point is point M. Likewise, we will define this short license cm as A. So here we can implement rule 65 in our circle. I'll repeat quickly on rule 65. Rule 65 is true in any circle, so this circle could be any circle. So in any circle, if chord AB intersects with chord CD, it's point O, then the following equation is true. AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. Can implement rule 65 in our drawing, because in our drawing we have this circle. In this circle, chord AB intersects with chord PC at point. Again, chord AB intersects with chord PM at point C. Again, in this circle we have chord AB that intersects with chord PM at point C. So it is now chord AB intersects with chord PM at point C. The intersection point of chord PM with chord AB occurs at point C. So we can implement rule 65 in our drawing. So according to rule 65, the following equation is true. AC times CB equals to PC times CM. Again, AC times CB equals to PC times CM. Repeat again. Now drawing, the following equation is true according to rule 65. AC times CB equals to PC times CM. AC is 7 times CB, CB is 2x minus 7. And it equals to PC, PC is 21 times CM, CM is A. So in total, according to rule 65, found out actually that 7 times 2x minus 7 equals to 21A. Here we divide this equation by 7 and get that here 7 get cancelled, and after leave 2x minus 7 this side of the equation. So it equals to 21A over 7 is 3A. So in total we found out that 2x minus 7 equals to 3A. Here we add 7 to this equation and get that 2x equals to 3a plus 7. In the next step, we will join points Q and M together by a straight line. By joining points Q and M, we can adhere the again triangle PQM. So this is again AMPQ, that is defined as peripheral angle MPQ, subtend on chord QM. Again, peripheral angle MPQ, subtend on chord QM. And it equals to 90 degrees in size. So here we can implement rule 5. bit quickly on rule 5. According to rule 5, any peripheral angle that is equal to 90 degrees in size must subtend on the diameter of the circle. So in the drawing we have a circle. This is peripheral angle MAN that subtend on chord MN. Peripheral angle MAN is a right angle. This is equal to 90 degrees in size. And therefore, according to this rule 5, any peripheral angle that is equal to 90 degrees in size, like this peripheral angle MAN, must subtend on the diameter of the circle. Peripheral angle MAN subtend on chord MN, and indeed chord MN is the diameter of the circle according to what is given us here. MN is the diameter of the circle. So repeat again. According to this rule 5, any peripheral angle that is equal to 90 degrees in size, like this peripheral angle, must subtend on the diameter of the circle. So we can implement rule 5 in our drawing. In our drawing, this is peripheral angle MPQ. That is equal to 90 degrees in size, and therefore according to rule 5, it must subtend on the diameter of the circle. Peripheral angle MPQ subtend on chord QM, and therefore according to rule 5, chord QM must be the diameter of the circle. The radius of the circle is x, therefore the diameter is 2x. So the diameter QM equals to 2x, units in its length. So in the next step, we will implement the Pythagoras theorem on this right triangle PQM. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the sides of the perpendiculars. So, according to the Pythagoras theorem, in this right triangle PQM, QM squared is the square of the hypotenuse equals to PQ squared plus PM squared. Here by PT is the position for Pythagoras theorem. Again, according to the Pythagoras theorem, on this right triangle PQM, the following equation is true. QM squared, that is the square of the hypotenuse, equals to PQ squared plus PM squared. QM is equals to 2x, it is the diameter of this circle, therefore QM squared is 2x squared. And it's equals to PQ squared. PQ is 16, therefore PQ squared is 16 squared, it is 256. Plus PM squared. PM in total is 21 plus 8, therefore PM squared is 21 plus 8 squared. So in total, according to the Pythagoras theorem, this means right triangle PQM, found out actually the 2x squared equals to 256 plus 21 plus 8 squared. We only found out that 2x equals to 3a plus 7. So we substitute 2x in this equation by 3a plus 7. If 2x equals to 3a plus 7, it means that 2x squared equals to 3a plus 7 squared. And it equals to 256 plus 21 plus a squared. So here we'll open the brackets on both sides of this equation. And we get that 3a plus 7 squared equals to 3a squared, that is 9a squared, plus 7 squared, that is 49, plus 2 times 3a times 7 is 42a. Equals to 256 plus 21 plus a squared. 21 plus a squared equals to 21 squared, that is 441 plus a squared plus 2 times 21 times a is 42a. So here we have 42a on both sides of this equation, so 42a will get cancelled. Also we cancel 42a. We left in this side of the equation with 9a squared plus 49 equals to 256 plus 441 is 697 plus a squared. So total, if we found out that 9a squared equals 9a squared plus 49 equals to 687 plus a squared. Here we will subtract a squared from this equation. And again that 9a squared minus a squared is 8a squared plus 49 equals to 697. Here we will subtract 49 from this equation and get that 8a squared equals to 697 minus 49 is 648. So in total we found out that 8a squared equals to 648. Here we divide this equation by 8. So we get that a squared equals to 648 over 8 is 81. So a squared equals to 81. Here we take out all this equation and we get that a, the missing 978a is equals to the square root of 81, that is 9. So a equals to 9 units in its name. So we already found out that 2x equals to 3a plus 7. So we copy this equation here. 2x equals to 3a plus 7. So 2x equals to 3a. A is 9, so 3a is 3 times 9, that is 27 plus 7. 27 plus 7 is 34. So 2x equals to 34. Here we divide this equation by 2 and we get that x equals to 34 over 2, that is 17. So if you want to know that the radius x of this semicircle is equal to 17 units in its length. Our task is to find out the area of this semicircle. So actually the area of a semicircle is equal to pi times the radius of the circle squared over 2. And again, the area of any semicircle equals to pi times the radius of the circle squared over 2. Therefore, the area of our semicircle must be equal to pi over 2 times the radius of our semicircle. The radius of our semicircle is x, therefore the radius squared is x squared. So total we found out that the area of this semicircle equals to pi x squared over 2. So it is pi over 2 times x squared. X is 17, therefore x squared is 17 squared. So in total we found out that the area of this semicircle equals to pi over 2 times 17 squared. So it is pi over 2 and 17 squared is 289. So if you don't know that the area of this semicircle, that is the area that we are looking for in this question, it is equal to either 289 pi over 2 square units inside, or in terms of numbers, the area of this semicircle equals to 453.96 square units in size. Again, the area of this semicircle is equal to either 289 over 2 square units in size, or in terms of numbers, the area of this semicircle equals to 453.96 square units in size. So finish with the second question. In the next step, I will start with the lecture. We start with the repetition of the first question, and then we repeat with the solution of this second question. In the first question, our task is to find out the radius of this circle. So in the drawing, we have a circle. This is line segment CP. This is equals to 12 units in its length. This is line segment AP. This is equals to 4 units in its length. This is line segment PB. This is equals to 4 units in its length. This is again CPB. This is equals to 60 degrees in size. Again, our task is to find out the radius of this circle. So first of all, it is given us a question that AB is a straight line. So if you focus on the upper side of the straight line AB at point P, here the sum of the areas must be equal to 180 degrees according to all three. All three state that the sum of the areas on one side of the straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line AB at point P? We have this angle that is equal to 60 degrees in size, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to all three. Therefore, this missing angle must be equal to 120 degrees in its size. The missing angle APC equals to 120 degrees in its size. In the next step, we join point C and B together by straight line, and we join point C and A together by straight line. By doing these constructions, we generate three triangles. Those two smaller triangles and the big triangle ABC that contains those two triangles. So in the next step, we implemented the law of cosines on all the three triangles. The green triangle, the white triangle, and the big triangle ABC that contains those two smaller triangles. So what is the law of cosines? I repeat quickly on the law of cosines. First of all, the law of cosines is true in any triangle. This is triangle ABC that could be in a triangle. Side AB equals to A units in its length, side AC equals to B units in its length, side BC equals to C units in its length. This is angle BAC is equals to 30 degrees in its size. And according to this law, the law of cosines, the following equation is true. C square equals to A square plus B square minus 2 times A times B times cosine theta. Again, C square equals to A square plus B square minus 2 times A times B times cosine theta. So we implement the law of cosines on all the three triangles, the green triangle, the white triangle, and the big triangle ABC that consists of those two smaller triangles. So in the first step, we implemented the law of cosines in this green triangle ACP. According to the law of cosines, in this triangle ACP, the following equation is true. AC square equals to AP square plus BC square minus 2 times AP times BC times cosine 120 degrees. Repeat again, this green triangle APC according to the law of cosine, the following equation is true. CA squared equals to AP squared plus CP squared minus 2 times AP times CP times cosine 120 degrees. CA is the missing side, so this is it is. And it equals to AP squared. AP is 3, therefore AP squared is 3 squared, that is 9. Plus CP squared. CP is 12, therefore CP squared is 12 squared, that is 144. Minus 2 times AP, that is 3, times PC, that is 12, times cosine 120 degrees. Cosine 120 degrees is equal to minus 1 half. So that we should know that CA squared equals to 9 plus 144 minus 2 times 3 times 12 minus 1 half. 9 plus 144 is 153. Here we minus times minus is plus. We have 2 in the numerator, 2 in the denominator, so 2 get cancelled. So in total this expression equals to 3 times 12, that is 36. So in total we found out that CA squared equals to 153 plus 36, that is 189. CA squared equals to 189. We took out of this equation and we found out that CA equals to the square root of 189 units in its length. This is side CA equals to 189 units in its length, and CA squared equals to 189. In the next step, we present the law of cosines on this right triangle CPB. According to the law of cosines, in this triangle CPB, the right triangle CPB, if we choose theta is 60 degrees, then the following equation is to CB squared equals to CP squared plus PB squared minus 2 times CP times PB times cosine 60 degrees. And again, CB squared equals to CP squared plus PB squared minus 2 times PB minus 2 times PB times CB times cosine 60 degrees. CB is the missing side, so it is this, so it is CB squared equals to CP squared. CP is 12, therefore CP squared is 12 squared, that is 144, plus PB squared. PB is 4, therefore PB squared is 4 squared, that is 16. And minus, so it is minus 2 times CP times PB times cosine 60 degrees. So that if you don't know that CB squared equals to 144 plus 16 minus 2 times 4 times 12 times cosine 60 degrees. So CB squared equals to 144 plus 16 is 160 minus 2 times 4 times 12 times cosine 60 degrees. Cosine 60 degrees is 1 half. So total we have here minus 2 times 4 times 12 times 1 half. We have 2 in the numerator, 2 in the denominator, so 2 gets cancelled. So this expression in total equals to minus 4 times 12, that is minus 48. So in total, if you found out that CB squared equals to 160 minus 48, this is 112. So CB squared equals to 112. Here we took out all those equations, and we found out that CB equals to the square root of 112 units in itself. This is the missing sign CB, this equals to 112 units in its length. So CB squared equals to 112. So in the next step, we define this angle CAB as alpha, and we implement the law of cosines on this big triangle ABC. If we choose alpha as theta, then according to the law of cosines in this triangle ABC, the following equation is 2. CB squared equals to CA squared plus AB squared minus 2 times CA times AB times cosine alpha. CB squared equals to CA squared plus AB squared minus 2 times CA times AB times cosine alpha. CB squared is 112, and this equals to CA squared. CA squared is 189 minus 2 times CA, that is square root of 189, times AB, that is 7, times cosine alpha. So in total, if you want to know that according to the law of cosines, in this diagram ABC, the following equation is shown. 112 equals to 189 plus 49 minus 2 times square root of 189 times 7 times cosine alpha. So here we have 189 plus 49 is 238 equals to 112, and we have here minus 2 times 7 is minus 14, so in total this expression equals to minus 14 times root of 189 times cosine alpha. So here we subtract 112 from this equation, so in this side of the equation we have nothing, that is to say 0, while on the other side of the equation we have 238 minus 112 is 126, and here we have minus 14 times root of 189 times cosine alpha. Here we added 126, we added this expression, we moved to the right side, that is to say we added to this equation 14 times root of 189 times cosine alpha to this equation, and total if you follow that 14 times root of 189 times cosine alpha equals to 126. Here we divided this equation by 14, if I follow that cosine alpha equals to cosine root of 189 times cosine alpha equals to 126. So here we divide this equation by 14, if I follow that if 14 over 14 is 1, so in this side of the equation we left only with square root of 189 times cosine alpha, and on the other side of the equation 126 over 14 is 9. So in total if you follow that square root of 189 times cosine alpha equals to 9. Here we divided this equation by square root of 189, if I follow that cosine alpha equals to 9 over square root of 189. Here we substitute 189 by 9 times 21, so in total if you follow that cosine alpha equals to 9 over square root of 9 times 21. The square root of 9 is 3, so inside those we have 3 with 21. So in total if you follow that cosine alpha equals to 9 over 3 times square root of 21. We divided both the denominator and the denominator of this number by 3. 9 over 3 is 3, 3 over 3 is 1, so we left only with square root of 21. So in total if you follow that cosine alpha equals to 3 over square root of 21. The next step I presented to you the following trigonometric identity that states that sin square alpha plus cosine square alpha equals to 1. Here we subtract cosine square alpha from this equation, we know that sin square alpha equals to 1 minus cosine square alpha. Here we took out of this equation, out of this trigonometric identity, and we found out actually that sin alpha equals to the square root of 1 minus cosine square alpha. But we only found out that cosine alpha equals to 3 over square root of 21. So we squared this equation, and we found out that cosine square alpha equals to 3 squared, that is 9, over square root of 21 squared, that is 21. So in total we found out that cosine square alpha equals to 9 over 21. Therefore we substitute cosine square alpha in this trigonometric identity by 9 over 21. In total we found out that sin alpha equals to 1 and cosine square alpha is 9 over 21. So sin alpha equals to the square root of 1 minus 9 over 21. Here we multiply by 1 by 21 and then we divide it by 21 in order to overcome a factor with this number. So in total we found out that sin alpha equals to 1 times 21 is 21 minus 9 over 21. 21 minus 9 is 12. So in total we found out that sin alpha equals to 12 over 21, the square root of 12 over 81. Here we divided both the numerator and the denominator of this number by 3. 12 over 3 is 4 and 21 over 3 is 7. So in total we found out that sin alpha equals to the square root of 4 over 7. We took 4 out of the root. The square root of 4 is 2. Inside the root we left only with 7. So in total we actually found out that sin alpha equals to 2 over square root of 7. Again, in total we found out that sin alpha equals to 2 over square root of 7 and CB equals to the square root of 112 units in its length. So in the next step, we implemented the law of sines in this triangle ABC. Repeat quickly of the law of sines. First of all, the law of sines is true in any triangle. This is triangle ABC that could be any triangle. The length of side AB is C, the length of side AC is B, side BC equals to angles in itself. This is angle BAC, that is equal to capital A degree inside. This is angle ACB, that is equal to capital C degree inside. This is angle ABC, that is equal to capital B degree inside. And this angle ABC is inscribed by this circle, and the radius of this circle is R. So according to the law of sines, the following equation is to A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the radius of this circle that blocks triangle ABC. Repeat again, A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the radius of this circle that blocks triangle ABC. So we can implement the law of sines in our drawing. We put in our drawing. This is triangle ABC, that is definitely inscribed by this circle. Why? Because of the fact that all the three vertices of triangle ABC lie in the circle itself. So according to the law of cosines, the following equation is true in triangle ABC. CB over sinus alpha equals to 2R. Again, CB over sinus alpha equals to 2R. Then again, the right triangle ABC, the big triangle ABC, according to the law of sines, the following equation is true. CB over sinus alpha equals to 2R. We already found out that CB equals to the square root of 112 over sinus alpha. We already found out that sinus alpha equals to 2 over square root of 7. In the next step, we substitute 112 by 16 times 7. So it is 16 times 7 over 2 over square root of 7 equals to 2R. So here, the square root of 16 is 4, so inside the root we have only with 7. So it is 4 times square root of 7 over 2 over square root of 7 equals to 2R. Here we move square root of 7 to the numerator and 2 to the denominator. So in total we found that 4 times square root of 7 times square root of 7 over 2 equals to 2R. So here 4 over 2 is 2, so this expression in total equals to 2 times square root of 7 times square root of 7 equals to 2R. We divided this expression by 2 and finally found out that square root of 7 times square root of 7 equals to R. Square root of 7 times square root of 7 is 7, so in total we found out that the radius of this circle, that is the radius that we are looking for, this equation is equal to 7 units in its length. So we finish to repeat on the first question, the solution of the first question. In the next step, I repeat on the solution of the second question of this lecture. In the second question, our test is to find out the area of this semicircle. So in the drawing, we have a semicircle. PQ equals to 16, PC equals to 21, AC equals to 7. This is angle in PQ, this is the right angle. Again, our test was to find out the area of this semicircle. So first of all, we define the radius of this semicircle as x. So, if the radius is x, then the diameter AB is 2x. What is the length of this VC 97 CB? CB equals to AB minus AC. CB equals to AB minus AC. So CB equals to AB, this is 2x, this is the diameter of this circle, minus AC. AC is 7 according to what is given in the question. So in total, if we found out that CB equals to 2x minus 7 units in its length. The next step, I completed this semicircle to a circle. Then we extended side PC by side line until it touches the circle. We define the touching point of the extended line side PC with this circle. This point is point M. We define line 7 cm as A. The next step we implemented the all 65 in our drawing. Get quickly on all 65. In any circle, this circle could be any circle, because all 65 is stored in any circle. So in any circle, if chord AB intersects with chord CD at point O, then AO times OB equals to CO times OD. And again, we have in the drawing a circle, this is chord AB that intersects with chord CD at point O. Again, chord AB intersects with chord CD at point O. So whenever we have two chords that intersect with each other inside the circle, then the following equation is 2. AO times OB equals to CO times OD. And AO times OB equals to CO times OD. So we can implement all 65 in our drawing. When we put in our drawing, we have chord AB that intersects with chord PM at point C. Again, chord AB intersects with chord PM at point C. Okay, again, our drawing, chord AB intersects with chord PM at point C. So all the requirements for all 65 are satisfied. Therefore, we can implement all 65 in our domain. According to all 65, the following equation is to AC times CB equals to PC times CM. Again, AC times CB equals to PC times CM. AC times CB equals to PC times CM. This equation is the implementation of all 65 in our drawing. AC 7 times CB. CB is 2x minus 7. And it equals to PC that is 21 times CM that is A. So in total, we found out that 7 times 2x minus 7 equals to 21A. Here we divided this equation by 7. If we found out that here 7 we get cancelled, we left only 2x minus 7 equals to 21A over 7 is 3A. So 2x minus 7 equals to 3A. Here we added 7 to this equation. If we found out that 2x equals to 3A plus 7. In the next step, we join points Q and M together by side line. By joining points Q and M, we can then begin right line MPQ. This is peripherical MPQ that subset of chord QM. Peripherical MPQ is right angle. So here we can implement all 5. According to all 5, any peripherical this equals to 90 degrees inside must subtend on the diameter of the circle. In the drawing we have a circle, this is peripherical M and N that equals to 90 degrees inside, and therefore according to this one, all 5 peripherical M and N must subtend on the diameter of the circle. And indeed, peripherical M and N subtend on chord M and N, that is the diameter of the circle. So according to this one, all 5, any peripherical that is equal to 90 degrees inside, like this peripherical, must subtend on the diameter of the circle. So we can implement all 5 in our drawing. When we put in our drawing, this is peripherical MPQ, is equal to 90 degrees inside, and therefore according to all 5, peripherical MPQ must subtend on the diameter of the circle. Peripherical MPQ subtend on chord QM, therefore according to all 5, chord QM must be the diameter of the circle. We know that the diameter of the circle is 2x. Why? Because of the fact that the radius is x, the diameter must be equal to 2x. So QM equals to 2x. So in the next step, we implemented the Pythagoras theorem on this green right triangle PQM. According to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in this green right triangle MPQ, according to the Pythagoras theorem, QM squared, that is the square of the hypotenuse, equals to PQ squared plus PM squared. And again, right triangle PQM, according to the Pythagoras theorem, QM squared, that is the square of the hypotenuse, equals to PQ squared plus PM squared. QM is 2x, so QM squared is 2x squared, equals to PQ squared. PQ is 16, therefore PQ squared is 16 squared, that is 456, plus PM squared. PM is 21 plus 8, therefore PM squared is 21 plus 8 squared. So in total, I should found out that x squared equals to 256 plus 21 plus 8 squared. We already found out that 2x equals to 3a plus 7, so the 2x here by 3a plus 7. So 2x squared is 3a plus 7 squared equals to 256 plus 21 plus a squared. Here we open the brackets on both sides of this equation. This equation 500, the 3a plus 7 squared equals to 3a squared, that is 9a squared, plus 7 squared, that is 49, times plus 2 times 3 times 7, that is 42a, equals to 256, plus 21 plus a squared. 21 plus a squared equals to 21 squared, that is 441, plus a squared, plus 2 times 21 times 8, that is 42a. So here we have 42a on both sides of this equation, so 42a will get cancelled. After we cancel 42a, this side of the equation we left only with 9a squared plus 49. On the other side of the equation, we have here 256 plus 441 is 697 plus a squared. So in total, if we found out that 9a squared plus 49 equals to 697 plus a squared. So here we subtract a squared from this equation, and when we found out that 9a squared minus a squared is 8a squared, and it's equals to here a squared gets cancelled, and left only with 697. So in total, if we found out that 8a squared equals 8a squared plus 49 equals to 697. Here we subtract 49 from this equation. If we found out that 8a squared equals to 697 minus 48 is 648. So in total, if you found out that 8a squared equals to 8a squared equals to 648. Here we divided the equation by 8, and finally found out that a squared equals to 648 over 8 is 81. So a squared equals to 81. Here we took out of this equation, and finally found out that a equals to the square root of 81, that is 9. So equals to 9. We only found out that 2x equals to 3a plus 7. So 2x equals to 3a. A is 9, therefore 3a is 3 times 9, that is 27 plus 7. So 2x equals to 27 plus 7, that is 34. 2x equals to 34. Here we divided the equation by 2, and finally found out that x equals to 34 over 2, that is 17. So if you found out that the radius of this circle, x equals to 17. Our task was to find out the area of this semicircle. Actually, we know that the area of any semicircle equals to pi times the radius of the semicircle squared over 2. Therefore, the area of our semicircle must be equal to pi times the radius of the circle squared over 2. The radius is x, therefore the radius x is x squared. So in total, if you want to know that the area of this semicircle, that is the area that we're looking for in this question, is equal to pi x squared over 2. X is 17, therefore x squared is 17 squared. So in total, the area of the semicircle equals to pi times 17 squared over 2. So 17 squared is 289, so the area of the semicircle equals to either, let's see, 289 pi over 2 square units in size. In terms of numbers, the area of this semicircle equals to 453.96 square units in size. Okay, thank you very much.